world we live in is complex yet simple, expansive yet minuscule, pristine but also polluted. Before humans' consciousness inhabited the earth, biogeochemical processes have been cycling chemical elements throughout our biosphere. Carbon, nitrogen, phosphorus, and sulfur are all essential to a healthy life for animals and humans alike. These elements cycle silently, day in and day out, swiftly maneuvering through the shadows of time. However, since the dawn of the Industrial Revolution, humans have been throwing these biogeochemical processes out of their native balances. Today, we are going to give you an inside look into how these processes occur naturally and how they are thrown out of balance by our greedy anthropogenic activities.
Freaking cars, man. Woo!
Hi there. I'm here to talk about the carbon cycle and how important it is to our biosphere. Carbon is everywhere, from the air I breathe in to the air I breathe out. It is the backbone of our world. Without it, we would not be able to sustain life on this planet. It's the backbone of all molecules also, from glucose to amino acids. It builds strong bonds between other molecules to create large complex organisms that are everywhere in our biosphere. So how does this cycle work? Well, first of all, carbon is naturally in our atmosphere. It is consumed by autotrophs, plants. Then those plants use photosynthesis to turn carbon molecules in the atmosphere into the plant body itself. Then a consumer like myself might come along and pick an apple off a tree. That apple contains carbon from the atmosphere that the plants used, or the plants use photosynthesis to turn that apple into that beautiful, delicious little treat. Then a consumer like myself eats that and releases that carbon back into the cycle through exhaling and using the restroom. Another cycle involved with the carbon cycle is related to our oceans. Oceans simply absorb CO2. They transfer that CO2 into small marine life and marine shells. And then finally, it is released back into the atmosphere as CO2. Not that complex, but very, very important to our biosphere.
Phosphorus cycle. Phosphorus originates in the soil and minerals of the lithosphere and starts as a compound, as an inorganic ion phosphate. It affects multiple ecosystems, aquatic ecosystems and land ecosystems alike, and gradual rock deterioration leads to releasing the inorganic ion phosphate to consumers via the absorbed into the soil or as a water solution. Phosphate absorbed by organic compounds in plants then form organic phosphate, which is then consumed by consumers and decomposers, and which in return leads to cellular respiration, and inorganic ion phosphate is then re-released, thus completing the cycle of the phosphorus cycle.
Oh, hi. Didn't see you there, but I'm glad you're here. While I have you, let's talk a little bit about the nitrogen cycle. Nitrogen cycles through our biosphere like other biogeochemical processes. 78% of our atmosphere is made up of nitrogen. However, this nitrogen is non-reactive, meaning organisms can't use it in chemical reactions. There are several ways in which this nitrogen can be fixed or made into reactive nitrogen for those organisms to use it in chemical reactions. This reactive nitrogen is used in chemical reactions that are essential to building macromolecules, amino acids, and DNA. And because it's so essential, reactive nitrogen is labeled as a limiting factor, meaning organisms need it to survive. This nitrogen can be fixed through natural ways and man-made ways. The natural ways include bacteria living in the root nodules of legume plants, and also through atmospheric nitrogen fixation, which is when a lightning bolt strikes down through the atmosphere and it's so hot and heavy that it splits the oxygen atoms and makes it available for nitrogen to bond to those split atoms. And this reactive nitrogen then falls down from the atmosphere to our Earth. Now, the human ways that nitrogen is fixed is mainly through the manufacturing process of fertilizers. Because our populations have been exploding and we need this increased amount of agriculture, we've utilized more and more fertilizers, and these fertilizers are high in nitrogen. And the problem there is that when it rains, this nitrogen from the fertilizers run off farm fields and into our watersheds, which then with phosphorus contribute to the over-nutrification of our watersheds and eventually our oceans, creating dead zones and other problems. Last but not least, we're going to talk about the sulfur cycle. So the origins of sulfur originate in the lithosphere, rocks, weather, and sulfur is released. Sulfur also gets released in the atmosphere from volcanic eruptions or as aerosols coming off, for example, sea spray. Why is sulfur important? Well, it is in proteins, hormones, and vitamins. And another key point to the sulfur cycle is that in nature, often sulfur and oxygen are linked together.
So, the biggest impact on the sulfur cycle is the addition of sulfur oxides released into the atmosphere and into the water. So right here in this lovely picture, you have emissions from cars releasing into the atmosphere and emissions from factories going into the atmosphere. And then that in turn is precipitated back into our water supplies.
Okay, so how does this imbalance of sulfur affect our ecosystem and our biosphere in general? Well, because sulfur can travel great distances in our atmosphere, it can affect forests, lakes, fishes, and it can cause some real damage. Some parts of the world have an imbalance in sulfur, and parts of these large bodies of waters are completely clear, and they look relatively healthy, but they have no life in them, no plant matter, nothing, because of the imbalance of sulfur in the system.
There's no doubt that anthropogenic fueled activities have been throwing these biogeochemical processes out of balance since the dawn of the Industrial Revolution. And what are we going to do about it? Well, as a society, we need to stop burning fossil fuels immediately. As a society, we need to change the way we get our energy sources and change the way we get our food.